Time sufficient.
Sufficient.
It's sufficient to solve the answers.
Okay, it was sufficient for the time was sufficient for the given questions, right?
Yes, yes.
Mhm. So anyone would like to say about any question which he got very hard or something tricky? We'll not discuss the question, we just take the feedback. We'll start with the week 9, I guess. We are in week 9, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So we'll start week 9 in 10 minutes. So before that, I would like to get some feedback.
Sir,
So
excuse me,
anyone?
sir.
Yes.
Sir, week 9 has got 20th as the last date for graded assignment, whereas the
Sorry,
next
it
week,
was by portal team. It is actually 24.
okay,
Yes, sir. It is updated now.
updated. Okay, I didn't see that.
So from now it will be around like 1 minute. Give me a second, please.
I have checked 1 hour back, sir. I didn't see now.
Okay, so week 9 is 17, week 10 is 24,
24. Okay, okay, right, sir.
and week 11 will be 31.
Okay,
So if I'm not mistaken, then from now all the assignment deadline will be Sunday. Earlier it was Wednesday, right?
yes,
So
sir.
to give you more time because of quiz, we actually shifted 3 days.
Yes, sir. We didn't open that till now. That's why I'm asking.
Yeah, I understand that thing, and that is why I am talking about these things.
Thank you, sir.
I know many of you have not even seen properly the week 9 content, but
Yes,
we
sir.
are in the session,
Yes, sir.
so we'll
Sir, is
talk
there
about
any-
that.
Sir,
Yeah,
is there any week 12 for city?
week 12 will be there, but that will be the summarized week. There will be no graded assignments.
Okay.
Acha, only 11 graded assignments.
31st will be the last graded assignment. After that, summary videos will be released to you.
Okay.
Okay.
Sir.
Yes.
Okay.
Sir,
Yes,
after end term exam, there will be some time like a vacation, or it will be starting directly.
It must be mentioned in the portal. I am not sure. It will be in August. Okay. So August last, I guess it is August month will be registration month.
Okay, sir.
Okay. So
Sir, after the end term, there will be a buffer, no? Before
yeah,
the...
there will be some buffer, 15 days, 20 days.
Okay.
I am not sure about the exact date. I haven't seen it, so I can't comment. But yeah, you will get some time. That for sure. Okay, so tell me how many of you have seen actually week 9?
Sir, I have, but not completed.
Up to 9.2, I have seen, sir.
Okay, so
I have seen till 9.6, sir.
I've seen
How many
9.3.
lectures are there actually?
7 lectures, sir.
7 lectures.
Seven-
I've seen 9.
7 lectures. Okay. So who has seen till 9.2?
Sir, me, sir. Shubham.
Lakshmi,
It's me, sir.
you have seen till 9.6, right? Shubham?
No, it's 9.2, sir.
I have seen till
9.2.
9.6, sir.
Yeah, I'm talking to 9.2. Okay, Lakshmi. So
Yes, sir.
the question is like, what did you see in these 2 lectures? Any difference from week 8?
Oh,
What is the main difference in this week? And what is the connection?
I
Sir,
didn't
can
get
I
it,
say?
sir. Still, I have to go.
Did
through.
not get
Sir,
it.
in week 9, we talked about matrix.
Yeah, Matt.
Matrix and
How to
graph.
arrange? Maybe I have to arrange them in matrix notation.
I'm not satisfied with the answer right now. Matrix is something like there was list, then dictionary. I'm talking matrix is the another way of representing graph, correct?
Yes, sir.
So basically we are in my graph.
Graphs,
structures,
yeah,
correct?
graphs.
Graph
nodes.
data structures.
Yeah.
And graph data structure is just the visual representation of something. What is that?
Nested dictionary.
Nested dictionary, correct?
Yes, sir.
And that is the connection. Am I
Yes,
right?
sir. Yes, sir. Yes, sir.
So if you just start realizing, then we started something called nothing, variable and count, right?
Yes.
In the start. Then we introduced one thing which is called iteration. After that, after iteration, we introduced filtering, then nested filtering. Then there was a procedure. After that, there is nothing, anything which came as a procedure or as a steps, correct? Did you get any new thing as a steps? Are you guys getting my point? What am I trying to say?
Yes, sir.
So we did not see anything like in terms of steps. You will see in the week 11, which is recursive algorithms. But till now, based on those three concepts, we just introduced list and iterated over it, correct?
Yes,
Yeah.
sir.
Same thing which we were doing with the tables, we did with list, correct?
Yes, sir.
There was nothing different. There was just the calling procedure was the calling or iterating loop was different, but the steps were same. The concepts were same, correct? So we introduced list because we had to give some collective data. We have to manage some collective data, collections of elements. Then we introduced list. List was a simple collection of the elements in, and one important thing about list was that it is an ordered collection. So order matters in list, right?
Yes, sir.
After that, we found that accessing some known variable is not so easy in list. We introduced dictionary which actually maps the variable to values. And then in dictionary, we introduced nested dictionary. Now in nested dictionary, we found that if you try to write a nested dictionary, there will be a lot of keys and a lot of values, okay?
Yes, sir.
Suppose if you want to find the authors as a key and the co-author as the list of co-author as a values. So see, visualize it. If there are thousands of authors, then how big it will be? Are you getting point?
Yes, sir.
There will be 1,000 keys and there will be numbers of lists, correct?
Yes,
Some
sir.
list will have 3 elements, some list will have 2 elements, or you can even make it more complicated. So we kind of found that this is being complex right now in visualization. So we introduce one more concept, which is graph. Graph is what? One kind of nested dictionary. From table dictionary, we introduce a graph. Graph is what? Connections between the nodes.
Notes, yes, sir. It is in
And
maths,
nodes-
sir.
Hello?
Actually, graph is in maths, sir, in week 10.
Yeah, I know that. And it is in city also.
Okay.
So there are two parts of that. The other things you will learn in mathematics. The algorithm part you will learn in city. Okay, so the concept is that we introduce the graph, and to represent graph, again there was a complexity that you draw a row and some you draw arrow, node, vertices, edges, which computer doesn't understand, right?
Right, sir.
For tailing computer, it's not like one arrow from here to there. So we introduced to represent matrix in represent graph in matrix form. So this was the evaluation from start you have joined, and this was just the motivation why graph came into the picture. Now the question is, what is the adjacency matrix? Anyone?
Sir, in this matrix, we we pick a what they call it, vertices, or I don't remember exactly. So we map it to the another edges, like many edges. One vertices can have many edges, something like that. I don't remember exactly.
Okay, Aditya, someone else, please.
All the neighbors of a
So a square matrix utilized to describe a finite graph.
Okay, so
all the neighbors of a particular node are so the combination of all the particular node and the neighbors of a particular node are grouped as one, and if they are not neighbors, then they are given as 0, something like that.
okay. So after listening to this, can I say adjacency matrix is a square matrix where if there is an edge between two vertices, it will be represented by 1, otherwise 0. Is that right?
Yes, sir.
Correct?
Yes, sir.
Okay. So if it is correct, then what is the diagonal elements in our course? Diagonal elements are zeros or 1?
Zeros.
All the diagonal elements are zeros, right?
Yes, sir.
We are not assuming that there is a connection between A to A. Okay. Okay, so this was a simple introduction. May I know the questions anyone have?
Sir, I understand the graph is in nested dictionary, but I unable to visualize how it looks when we map it to student data set. What is in column, what is in row? I don't understand this.
Okay. So let's do an example. Okay. I'll take. Just let me know my screen is visible.
Sure.
Yes, sir. It's
Okay, so I don't need this part, and I need one thing which is okay. So this is course data set, okay?
Yes.
And I am representing a task, which is I am saying that to make this one more thing I can do is okay. So there is an edge from A to B. Okay. So let let G be a graph on scores data set such that every node is the sequence number of a student and there is an edge between student A and B. Now A and B are actually the sequence number. I am saying them student, okay? The student A and B. Okay, so not between, from student A and A to B. If the score of A is greater than B, but not more than 10. Okay.
Yes.
Are you getting what I'm trying to say? So there is a graph from in student's data set, and the graph is such that every node of the graph is actually the sequence number of the students. And so if there are 30 students, then how many nodes will be there in the graph?
29, 0 to 29.
So it's 30, 0 to 29, right? Numbers is 30, but it's from 0 to 29, right? So the question is that why are we using sequence number? Okay, we can use anything as we used in the nested dictionary. Keys were not supposed to be integers, right?
Yes, sir.
If the graph is another representation of nested dictionary, then why graph is always having this 0 to 10 or 0 to n minus 1 numbers? Is that 10? Does anyone know the answer for that?
Sequence numbers are unique, sir. So it represents a particular student.
That is also right. One more thing.
Sir, we are talking about row and column, so we are taking numbers only.
That is also correct. Then
Is it because of the order of the card?
so there is one more reason that there are many operations can be performed with the integers, right? If I have to add two sequence numbers, that doesn't make any sense. But yeah, that doesn't make any sense. But it's totally easy to call them by numbers. Okay, if you have to perform from 1 to you want to find the alternative sequence. Okay, in sequence number, if you want to find alternate number, then calling by name is difficult. You can say j every student mij, where j is j plus 2. So it will leave the one students, correct? The never student, it will be dropped. Are you getting my point? So for example, if you want to access and so if you have seen the lecture, then you might be seeing that mij is written everywhere. Okay, what is mij? I is the row and j is the column number. I is the row number and j is the column number. Okay, so if you want to find the student who are actually odd positions, then it's very easy to that j equal to j plus 1. You can start j equal to 0, sorry, j equal to 1. Even you will leave the first element, then plus 1, rather than plus 1, you can do plus 2, as you have done in the paragraph dataset, which is words dataset, to access the letter of words, right? Okay, so I don't think it is right time to talk about this, because many of you have not seen whole lectures. So okay, that leaves for now. We'll go to the so sequence number are unique, first thing. Second thing, it's easy to iterate over that. Okay. Third thing will be clear once you go through the lectures. Okay. So we were how graph is actually being constructed and then converted to matrix from the course data set, right?
Yes.
So let's check one more thing. So I have to do this. So I can take here. Okay. So this is my graph, and I want to create a graph. So I have data set, correct? So what is the sequence number of this student? It is 0.
Zero.
What is the number? So which total score we are talking about? Okay. Total score. Okay. What is the score of this guy?
210.
It's 210.
210, sir,
Okay.
210.
210. Okay, what will I do now? So it's sequence number 0 and 210. Okay. So second is the marks, so that we recognize what is going to happen. Okay. Can anyone tell me what is the sequence number of what is the total mark of the sequence? It's 198. Will there be a age?
No, sir.
No, sir.
No, because it is actually it is more than it is 12 marks. I want only 10. Na? So one has 198, right? 98. Okay. So basically, okay, what is the third student? It's 188, correct?
Yes, sir.
And I understand this will have one edge.
Yes, sir.
Okay, from where to where?
From second to third. I mean, from 1 to 2.
1 to 2, correct?
Yes, sir.
From 2 to 1, no?
Bigger to lower we are going.
Okay.
So the question is, if the total score of A is greater than B but not more than 10. Okay. So A to B when A is greater. Okay.
Yeah, highest marks student will help the lowest. It will help the.
Okay. It is 73. What will happen? Anyone?
No, sir, it will not.
So no connection should be there.
Yes, sir.
Yes, sir.
No connections will be there. Am I right?
Yes,
What
sir.
are the marks?
173.
173. 173. Okay. Now, next person is 240. I guess no marks.
No age.
No one is no age now. Okay.
Yes, sir.
Four, 240. Okay. Next person. 247. Oh, so I guess
It
I
will
should
go,
put
sir.
it here. And there is no there's no definition that where I should put. I'm just putting so that I can see clearly which is from where to where the node is. Okay. 247. Okay. $247. Now I'll have one edge from here to here, which is okay. But I think I should be showing the rows. So
Arrow, sir.
okay. Is that right?
Yes, sir.
And one will take 10 students so that we can complete so fast. 250. What is your thinking now?
Sir, it will map to both, sir.
4 and 5.
247 and
240
Yeah.
will map to 247 and 240, right?
yes, sir.
Excuse me, sir.
Yes.
Sir, can you explain that mapping part once again?
So
I
we
got-
are mapping. So there is a age. Age has an arrow. Okay. So
Right, sir.
from one student to second student will be an arrow. When the first student has more than has a greater total score, but not greater than 10, not more than 10. So at least 10. So at most 10 difference. Okay.
Okay.
So it's not difference. It's the subtraction. Difference means vice versa. No?
Right.
Okay. So it's one way only.
Okay.
So what was it? 250, correct?
Yes, sir.
Yes, sir.
So 250 will have what?
So it should be
From
6,
here to-
250.
Okay, I'll correct it. Thanks. Okay, so okay. Now next question. 252. Oh my god. They are going to get many connections, right?
Yes.
252 is right. 7 252. What was that?
7 to 52.
7 to 52.
252. So 252 will be so see, I am not following any sequence. Where should be up or lower? So don't get confused that always in the graph someone is high marks or will be on the top. This is not any necessities.
Sir, no, it should be from
Sir,
6 to
7
5.
to
Yeah.
6, sir.
it's wrong, sir. 4 से नहीं होगा.
7 to 6.
And to 6.
Okay, we have 7 students now. That's one. $189. Where should I put it?
Sir. 189.
2, 1 and 2.
88. 288. 188.
So it will govern. It will be governed by 189, but I mean it will be mapped by. There will be an arrow from 198 to
189.
189, and from
Sir, 189 to 188.
right. So
So the arrow should be pointing the opposite direction.
Hmm.
okay. What was the sequence number of this person? 8.
Yes, sir.
Yes.
Let's take one more example. 224, and what about 224? No connections, I guess.
No connection.
No connection. So I can. So there is. I am not sure if it is in the week 9 even. I'll just check it. Concept of the students. So can anyone say, is it a connected graph or not? If you have seen the lectures.
It is not connected graph.
Sir, actually, for connected graph,
No, sir, it's
difference-
not a connected graph.
Professor has taken difference of 10 marks to 20 marks. And where we have taken is only 0 to 10. So it will
That
be
doesn't
similar
matter.
pairs.
My question is that the connected graph or not? Just
No,
a simple
sir,
I
question.
guess it is a connected graph, sir.
You guess why?
There are connections between, one student and the other student. At least for some of the students.
Yeah, and
Here the
there are also some cycles.
purpose of helping one student to another.
I didn't say there is a there is helping going on. I didn't say anything. I just said there is an ace from a student if he has at most 10 marks from the other student. That's all.
Okay.
I didn't
so
say
that-
what is going to happen. Okay.
See, these
So
students are
absolutely.
related to each other based on your condition. So they are connected.
Okay. Anyone else?
Sir, they are connected, sir.
So it's disconnected because it has multiple components. Multiple connected components.
Anyone else? Multiple connected is connected.
It's not a connected graph because we cannot reach from every node to every other node.
Yeah, cycle is not problem. There is no cycle.
So it's not connected. Connected means if you start from one node and you go by connection, you complete all the
Nodes.
Okay. That is called the connection. Okay. Did anyone hear about the click?
Yes, sir.
Yes,
What
sir.
is that click? Is the click we are seeing or not here?
No click.
No click.
Yes, sir.
Can you see the upper triangle?
1, 8 and 2, they form a click.
But that's only for similarity.
In click, there is no arrows. No?
Direction. Yeah. There's only
There
for
is no
similarity.
direction in
No direction.
So what is the final answer?
There's no click.
It's a click or not?
No, sir.
No. No, sir.
Okay, I'm leaving.
No,
I'm
sir.
leaving this to you. Go and see the lecture. When you see this graph, remember it. Is it a click or not? Okay. Okay. So we created a graph. Okay. And is it visible graph
Yes, sir.
or should I zoom? Okay. So the thing is that we created a graph and every node is the sequence number of student, means every node is representing a student and there is an edge from the A to B if A has greater than at most 10 greater than total marks than B. Okay. Now if I represent this in a sequence dictionary, can anyone help me? How should I represent it?
A sequence number as key and marks as values.
Someone was chatting in the chat that either integer not the keys. I did not say these things. I told there are many keys and they are, keys are string, string and integers both. But in graphs and matrix, we are only using integers. Is there any reason behind? or we cannot use the string? Does anyone tell me? Will anyone tell me why? Can we use the string in the graphs?
The issue with using string in graph. Anyway, we are going to
As keys,
track.
sir.
No, sir, we cannot use a string in the graph.
String means to represent the nodes only, not the SS, not the 1 and 0.
The nodes can be strings, right?
Yes, sir.
I mean, the student name can be the node, right?
Correct. It can be.
Anyway, it's going to be accessed through the key only, right?
So if we have unique name only, then we can have, okay, all the name are distinct, then we can use them as the
node,
rows and columns. Is that right?
Yeah.
Just for our simplicity, we are using integers. Why we are using? Just for our
Convenience.
Simplicity. Convenience, you can say. Okay. So I'm creating a greater, and I'll start with the dictionary. It will be a then you can do how will you want to create a dictionary with list or a nested dictionary?
Nested dictionary.
Nested dictionary.
So there is 0, which is mapped to nothing, correct? Guys, give me a second. 2 minutes. Huh? Okay. क्या किया इसने? क्या? पानी बाहर आ रहा है। इसको बुलाओ। खींचो। ए बाबू, बाबू। बुलाओ तुम भैया। जोड़ सो आप इसको बुलाओ। तो बात छोड़ रहा है। यहाँ से भी पानी आ रहा है क्या? तो वहाँ कुछ रख दो। अच्छा रहेंगे, चले जाओ तुमको, मैं ऐसे बंद कर रहा हूँ। अरे चिड़िया काफी पनिया देखा तुम्हें? टेप मार ले। कहाँ से पता चली? देखा घींचा था क्या? वही जाता। अब ऊपर क्या होता था? जब कहा था ऊपर आप चले जा रही। कर ले ढलान में रह चाहिए। अरे मोदी अब गिर था। इसको बोल के जल्दी कर रहे। और जैसे ना गिरा था। और जैसे ना गिरा तो जब भीगल लाता है वो। डरान में रहे। चलो निकलो जाओ, मीटिंग चलो। अब आएंगे। अब ला देता पे क्या? छटका ला पे क्या? जल्दी कर। चलो जाओ.
George.
Hello. Am I audible?
Yes, sir.
Yes, sir.
Was it unmuted?
No, sir.
No, sir.
Okay.
Yes, sir.
Actually,
Unmuted, sir.
my AC got leaked. I don't know what happened. I just got new AC.
We listen
so-
everything.
Okay, sorry. Okay, so where was I?
Sir,
Nested
we
dictionary.
were
Creating a
making.
matrix.
Okay, so we were creating a dictionary, right?
Yes, sir.
Then one is mapped to what?
One is mapped to 8, I think.
One is mapped to 8. 8 and
8 and 5.
8 and 2, correct?
Okay.
Sir, your
Sir,
screen is
your
not
screen
visible.
is
Sir,
not
your
visible,
screen
sir.
is not visual, sir.
Okay, I closed the screen rather than the mic. Sorry. You could have interrupted me. You guys were listening. Very bad manners. Okay, so one was mapped. One is mapped to 2 and 8. So 2 will be true, and 8 will be true, correct?
Hmm.
And then
5, 3 or 5.
3. 3 is what?
No, not mapped, sir.
4.
4, no, sir. Yes, 4 is. No, sir.
Where is 4?
4 is not mapped, sir. Yeah, 4240.
4 not mapped. 5.
5 is mapped to 4, sir.
From 5 to 4. Okay. Okay, so this is how we will do. Am I right? Are we getting my point?
Yes,
So
sir.
this is how we can create the dictionary. But once we create dictionary, the same thing happens what earlier were there. But remember, if there is we were using again and keys of this, then keys of this, then keys of this, right?
Hmm.
Here we can just create a matrix, and that suppose I'm saying greater mat is my matrix, then it will be like how many rows we have
10, sir.
and how many columns?
10.
10 rows, 10 columns means 11 and 11. If I'm not wrong.
No, sir, 10. 0 to 9 is there, no?
0
Yeah,
to
so
9.
we will need to take so this will be 0 and this will be 0 actually. 1,
Hmm.
2,
2,
3, 4, 5, 6, 7, 8, 9. Is that right?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9. 0 was not mapped to anyone, correct? So what should I write?
0.
False.
So this is how we are going to end. This is called adjacency matrix.
Okay, so 0, 0.
Okay, what about 1?
Sir, 1 first 0 and then
1 is
second
mapped to
0.
2 and 8. 2 and 8 are true.
Third में 1 होगा.
2 and 1. 8 and are 1. Others are?
Rest are all
0.
zeros.
And what about 2?
2, 0.
2 we have not written even in the dictionary, we forgot. Okay. So 2 is not mapped to anyone actually. So okay. So 2 is mapped to nothing, 0. 3
is also 0.
4
0.
5
is
5,
mapped to 4.
1. 5, 4, 1.
And none after that. 6
is
6
mapped
is
to
mapped
4
to 5, 4
and 5.
and
6 is
4
mapped
and
to
5.
4 and 5. 7
सर ऊपर करिए.
7 is mapped to 6, 5
7
and
is
6, right?
5 and 6.
5 and 6.
It is mapped to
2.
8, 2.
8 is mapped to
2
sir.
only, sir. 2.
Just 2.
okay. 9
9, 0.
1, sir. 1.
No,
That,
0,
you put 2,
0.
sir. It is 1.
Sir, it's 1.
all 0, sir.
All 0, sir. 9 is 0.
Okay, so there are many questions we can answer by seeing this only,
In
right?
8, 2, you have put 2, sir. It should be 1.
It's 1. It's 1, sir. Yeah.
Okay. Fine. So by this, we can answer many things. First thing, that 1 is connected to 200. We don't need to check where 1 is and where it is connected. Okay. Other thing, if you want to check how many connections are there, you can add it row wise and you will get actually equal to 2. Is that right? Sorry, it's column wise. If you add column wise, you will get 2. Am I right? And every rows can be accessed. Like, what is this? Which row is this?
1, 2.
Second row. Second row.
So it is first row, sorry, second row, which is 1th row and 2th column. Okay.
Column.
So this is actually, if I want to access this one, it will be, my matrix is the greater math. So it will be 1 and 2. Okay. What about this?
7,
5,
6. 7, 6.
7, 5, 7, 6.
So which one is rows is 7?
Row is 7 and one column is 5 and other column is 6.
Okay. So this is how we will actually work with the matrix, how to access and not to understand this and everything. Okay. My question is, has sir covered the pseudocode also in this week?
Yes, pseudocode is covered, sir.
Yes, sir.
Okay, so what was the name of that student who
Yes, sir.
asked about this? Is that clear now?
Yes, sir, it's clear.
Okay. So the pseudocode in that, we start with the, do you remember how we were initializing the variables?
Oh, sir.
Initially, every entry equals to 0.
So we were doing 0, mainly initializing something 0. When we were initializing dictionary, how were we initializing?
An empty dictionary, sir.
An empty dictionary, correct? And list?
Empty list.
Empty list.
So the same way, how will we initialize the matrix?
We'll also, sir, initialize it as an empty dictionary.
So mostly so our emptiness is the 0, correct here?
Yes, sir.
Yes, sir.
So in the pseudocode, we have assumed that if we write like that, equal to
Initialize with 0.
create matrix n comma n. It is actually the initializing a matrix with zeros where matrix of n rows and n columns where every entry is 0. Okay. So this all will be 0. If I write 9 comma 9 for this, if I have to create this, then I have to write 9 comma 9. Okay. Sorry, 10 comma 10. So n means 0 to n minus 1. So rows are where the rows are 0 to
n minus
1. Okay. And columns will be
Again 0 to n minus 1.
Same, sir.
okay. So same 0 to 1 minus 1 and 0 to n minus 1. What about then how we will go through the, so suppose where I have to do this. So I have to create this matrix, great matrix. How will I create? Anyone? So I'll create a pseudocode from now. Initializing part will be very clear, I guess. So create matrix n comma n. So it will be 10 comma 10. Okay. Is that right?
Yes, sir.
Then tell me the procedure. What should I do then?
We have to go through each and every row of and column of a matrix through a for each loop.
So for each loop,
for each rows.
For
So
each I
here
in rows of great matrix.
Correct. So for each
row
in rows,
in
for each
row
sorry.
and row, yeah, for each I in
For each in
rows of greater mat.
rows of greater mat.
And then again for each j in
for each j
in columns of greater mat.
Columns of next.
Next, if greater mat of I comma ij or we have to calculate the difference between the marks first.
So how will I say marks?
It is, I
at
mean,
most
in
10.
the dictionary, right? In the first dictionary, you have computed the value of each I and j, right?
So we are actually in the we have done a mistake here.
We have to,
Because
I mean,
we
first
have
create
not-
the dictionary.
Correct. So dictionary we did not create it. So rather than creating dictionary, what else I can do? So this is fail, correct? Because we don't know what to do.
Yeah.
So next thing is that
you have to.
What we have done till now is that while there are more rows in the scores data type. Do you remember now?
Yeah, while there are more rows in table 1.
More rows in
table 1.
1.
Read first row X from table
Read
1.
First
row X in table 1.
1. If I have it, then move it.
Then move to table 2.
Move
X to table
X to
table 2.
Again, I need to check for. Again, I need to take.
Read first row Y in
Y.
table. There are more rows in table 1.
While there are more rows in table 1,
read first row Y in table 1
and move Y to
table 3.
Why table 3?
Because we have already compared it, right? Or no?
Correct. So we have compared it then.
So then in last, you have to move all the table 3 row to table 1.
But there is a mistake again. So earlier what we were doing, we were comparing, but whenever first is being chosen, it was sending to table 2 and then not getting it back, correct? But here that is not the case. In matrix, every students are there in the rows. Every columns have the student, right? So I have to check 0, 1 and then 1, 0 also. Is that right?
Yes.
Am I correct or not?
No, but if 0 and 1, if 0 is greater than 1, then 1 is always lesser than 0.
Correct. Then I can do directly.
Yeah.
I can directly do the two updation, correct? Ij and ji.
Yeah.
Okay. So what should I do? Now the filtering steps.
So if X dot max minus Y dot max.
Y max? Where is max?
Or the subject, I mean, total, sorry. Total.
Total.
If X dot
total
is greater
minus Y dot total
minus Y dot total
less than or equal to 10.
Then?
So we should take
See, is it at least or at max, sir? The value 10?
At max.
Then less than or equal to, right?
Okay.
0.
Then
This.
greater matrix of X Ij is equal to 1.
Where is
or
I?
here, I mean, there is no Ij, right?
So
Okay.
X dot sequence number and Y dot sequence number.
Okay.
So 0 is less than this, difference is less than.
X dot sequence and Y dot sequence.
Someone is saying something which who is that person is right, will come back. So you are missing something. Are you getting that?
So also the difference should be greater than 0, greater than equal to 0.
Sir, absolute value.
Oh, greater than
We
0.
should take.
Equal to 1. Is that right?
Yes.
And the simultaneously I should make the opposite 0. Is that correct or not?
No, it is already 0, sir, the opposite. Because it is when you're creating a matrix, it is initially to 0, right?
Correct. So if it is in a slice to 0, am I right?
Yeah, you don't have to implicitly again put it to 0, right?
Okay. So my question is, suppose the first card is having the what is the first card? Okay, first card is actually 0. Okay, 0 is not having any connection to anyone, but one is actually more than 2, correct? More than 1, 2 and 8. Is that right?
Yeah.
So that is that you will get. That you will get by sure. That you will get. But what will happen if I take randomly this? 8 is actually having more than 1.
Okay. Then,
So then
1 and 8 will be, it will always be less, right?
So 8th card is greater than 1, okay?
So eventually first card will be lesser than 8.
Huh. Okay, so my apologies. Let me make this. Okay, 1 and 0. Okay. Now tell me.
Okay. So if first card is greater than 8, then 1 8 will be 1.
So I'm saying now 1 8 is not 1. 8 1 is 1.
Now 1 is not greater than 8. You see,
now
1 8 is 0 now.
Now 1 8 is 0. 8 1 is 1.
Okay.
And now table 1 has no rows to compare with.
Correct, na? Are you getting where I'm pointing out?
See, instead you, take these values, store in a dictionary, then you need not do all this thing, no, sir.
So you are asking me to do the double effort, correct?
Like you first create a dictionary, and then you create a matrix by referring to that dictionary.
So you are saying me to create first dictionary and then do the matrix, right? Which is the double
Yes,
thing.
see, in the dictionary, we will store the sequence number of all the marks.
But in this way, you will first create a dictionary. So you are doing one iteration and one comparison, right? After that, you will do the keys by keys. So second of comparison, which is not a good way, no?
Okay.
Okay, anyone else who would like to interfere here?
So every row of table 1 should be compared with every remaining row of table 1 and the rows of table 2 also.
Again.
Every row of table 1 should be compared with remaining rows of table 1 and the rows of table 2.
So by this way, you will go one by one and never will be completed. Am I right? So again and again, if you are iterating the same card, never will the day will never end. Is that right or not?
So, but we are moving table 1 after comparing to table 2 also.
So you are saying that again compare with the table 1.
Remaining rows of table.
See, now here you have moved this Y to table 3, sir. Now you are comparing one with the first record of table 1.
Yeah, I know what will you say. That is the move all the rows from table 3 to table 1.
Yeah.
Right. Still we are losing the one information.
So the difference should be greater than 0 also.
That is very good point, because this way you are actually making minus also, taking minus in the.
Or you can take the 10 in the beginning, 10 greater than or equal to x total minus y dot total. You can reverse the condition, sir.
Reverse the condition means
10 greater than or equal to x dot total minus y dot total.
That won't make a difference.
That won't make a difference. Okay,
Also,
so
sir,
what
we will
we
have
are
an
trying. Okay, try to think what is happening. So if I compare 0 to 1 to 1, 1 to 2, if 1 is greater, then I am supposed to write 1, right?
Yes.
Okay, so if it is greater than 1, otherwise
we should have a else block that does the same thing, but y dot total minus x dot total.
okay, so if 1 is not greater than 2, then I need to check if 2 is greater than 1 or not. Is that
Yes,
right?
sir. Yes, sir. So we will have an else if block where we will do the checking in the reverse order, as in y dot total minus x dot total must be less than equal to 10 and greater than 0.
Correct. So one more if block will actually work, right?
Yes, sir. It should be else if, because so that
no, not required. No, else if this condition is true, then this condition will not be true. Is that right?
Yes, sir.
Am I right or not? Tell me.
Yes, sir.
And then I'll move
Isn't
and
it
reverse.
0 less than equal to, sir?
Not less than. Equal we are not taking. Equal will be 0 actually.
So you are trying to do this without the for each loop, sir? You are trying to do the matrix creation using the while loop only?
So matrix creation, we are using while loop, but okay, so for each loop will be used when there is at least there is something into the matrix, right? Otherwise everything is 0. And if you want to change, then we need to access somewhere. The one way was that you told me to create a dictionary, correct?
Yes.
So this way, if you want to access the randomly, the deck, is that also fine? But we did not take.
Yeah, see, if you are using a for each loop, then the second if statement is not required at all. What you have did in while, because see, I comma j, once the j value completes, automatically at some point j comma y will automatically come.
Correct. That is totally right. So in matrix, there is a more benefit that you don't need to do this. Okay. Okay. So one thing. So now I think we are okay with the procedure, but there is one more thing we can change actually. Can anyone tell me why?
In which part, sir? The same.
In this whole pseudocode, there is one thing which we can change. Its number of the iteration can be reduced, because we will get the correct answer by this code. I hope correct answer. If anyone have any doubt, please ask. So by this way, you can get the correct answer, but you can actually do something more. And that do something is like, okay, so when you are comparing 0 to 19, then you actually are comparing with other values with 1, correct? You get my point. You are comparing this and simultaneously you are comparing this also in this line. Sorry, in this line, one is here, okay? In this line, you are also comparing. Am I right?
Yes. So you want to say, I mean, you want to already check whether this value is 1 or not?
No. My point is, are you not going to check double?
Yes, sir.
No, not required actually. This is fine. Because you are already moving the rows, so no problem.
Yeah.
That will come into the matrix. So cool. Now we are actually moving the rows. That why it will not come into the picture. Otherwise, in matrix you need to check if I is greater than j or not. Otherwise, everything will be double. as he said that I after I j will come. Okay, so if you do two conditions, then you need to do check of I is greater than j, or as he is doing, that earlier part was like what, this part. So you don't need to do anything. You will be finding I, j, ji. So no need to think about.
Sir, if I is
But
greater than j, then the values which are lesser than I, those columns will not be skipped.
No, not skipped here. Not skipped.
See, for example, if I is 4.
Okay.
So I need to account for 40, 41, 42, 43. What I don't need is 44. Because you cannot compare that value with the same value. So the condition should not be I equal to j. That is what we need to skip, right?
So you don't
If
need
at all
to
we want to skip something.
It's not that much of effort. Okay. You can put I not equal to j, but it's not that much of effort compared to the number of iterations you are doing. Okay.
Yeah. Okay. Because we anyway need to skip the main diagonal, which is of no use for us, comparing the same value to itself.
Correct. So if I is equal to j, then you can skip by yourself. No problem. You can add in the condition always. So my question is that fine for everyone now? Got a little bit sense of what is graph now, what is being in matrix, what is how the pseudocode is working here. Anyone has any doubt? So no doubt so far because you did not study, correct?
Yes, sir. Sir, your screen is not visible, sir.
I'm not showing anything right now.
Okay, sir. Then it's okay.
So please, can you explain what is click?
Okay, so click is what? So earlier we were talking about here that this could be a click when this is a. Sorry, I did not present one. So click is what? In a group of nodes, every node is connected to each other. Did you get my point?
Yes, sir.
So if 1 is connected to 2, 2 is connected to 8, then 8 should be connected to 2 and 8 should connected to 1. But it will come when the graph is undirected. This is the directed graph, right? Am I clear?
Yes, sir.
For example, if you take the grouping of, you map with the student who are from the same city. So if there are three students, Rahul, Rohit and Rajan, and these are from the same city, then Rahul will be mapped to Rajan and Rohit. Then Rohit will be mapped to Rajan and Rahul will be mapped to the Rohit and Rajan, right?
Yes. Yes, sir.
So this is a click. If I show like this, okay, so if I get, let's make it, okay. So can you see this upper triangle?
Yes, sir.
Yes,
This
sir.
triangle is visible. So 1 is actually connected to 2 and 8, okay? Similarly, this is the undirected graph because there is no arrow. 8 is connected to 1 and 2. In the same way, 2 is connected to 8 and 1. So everyone is connected with a remainings. So So this is called the click. So click is a connected part of a graph. Okay. So connected means what? Every node is connected to each other. Sorry, not each other. Connected means if you start from a row nodes and go by the edges, you can cover all the nodes. That is called the connected graph. Click is that part of the graph where each and every row nodes are connected to each other. Okay. Same thing if you see here, then 6 is connected to 5 and 4, but 4 is not connected to 6. Okay.
Sir, will it mean 5 is connected to 6 also, sir?
No, this means 5 is not connected to 6. Because
not here, sir, in place of click.
Yeah, in place of click, all this, if you replace these all rows with the
undirected, I mean without arrow.
Without arrow.
Yeah.
Then you need one more arrow, 4 to 7. And then it will become a click. I guess it will become a click. Because,
5 to 7. We need one more arrow, sir. 5. Okay. 5 to 7 is already an arrow. Yeah, there is an arrow.
Yeah.
So 4 to 7, we need one more arrow. Okay.
Okay, sir.
Okay, so
Sir,
this is okay.
Sir, on similar lines, there is an activity question. Can you explain that?
Which question?
Click 9.3 activity. Question number 5. I thought everything was a click.
So which of the given lists represent a click? Okay. 2, 3, 1 is a click. Is that right?
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
So 1, 2, 3 is a click. Now 1, 2, 3, 4. 1, 2, 3,
No, sir.
4. But 4 is
No,
not
sir.
connected to 2.
It's not a click because 2 is not connected to 4 directly.
Okay. I got it.
1, 2, 3, 4, 5. Again,
Also not a click because 2
1,
is
3,
not
4,
connected
5.
to 5.
It is a click.
Yeah, 1,
2 is
3,
not
4, 5
connected
is a
to 4.
click. So click
No,
will
sir.
be like, you understand? So see, when will be a click? How many nodes are there?
4 nodes.
4 nodes.
4. And every node has 3.
Is connected to every other node.
So for that, n minus 1 edges should be passed from one node, right? Leave these 2 nodes because these are going to outside.
There are n nodes and there will be n minus 1 lines.
N minus 1 lines, okay? And those are connected to the nodes in the click which you are actually thinking about, okay? Because 3 is actually having, so for example, in this way, 2, 1, 2, 3, 4, okay? So there are 4 nodes, but 4 is actually having 3 edges. But this edge is not going to the part of click which you are thinking, right?
Yeah.
4 to 5. So that you need to keep in mind. Is that clear?
Okay.
Anyone else?
In the same, lesson 3, activity question 3, you have some question about the telephone booth. Like 15 telephone booths can be connected exactly with.
You are asking the question or you have a confusion?
No, I have a confusion there, sir, because the explanation which is given for the answer, I don't know how this explanation came.
Okay.
The question before, the third question.
Okay, so what is saying it? Consider there are 15 telephone booths on an island. It is possible to connect them with wires as that each telephone booth is connected with exactly 5 other nodes. Okay, so you are not getting that point, right?
Yeah, I got the answer. It is no, but through a different logic. But the logic defined here. See, my logic, how I calculated, sir. If 15th telephone booth, if I take, okay. If I draw 5 edges from 15 to 14, 13, 12, and 10, 10, okay, 12, 11, and 10. So up to 10 to 15, it is gone. Now I take the 9th booth. I connect till 9, 8, 9, 7, 9, 6, 9, 5, 9, 4. So up to 4 is gone. Now I have only 3 booths, and I cannot connect 3 booths to 5 booths, because if I connect, it will go more than 5, any other node. So that's how I derive the logic that it cannot be connected.
Okay, so take 10,000 telephone booths and 15,000 connections.
Okay, I cannot do that. See, what I did is, like, if it is a 15 telephone booth, okay.
No, what I am asking, did you get my point?
Yeah, I understand, because since it is a small number, I could do that way, but it is a big number, I cannot do that way.
Okay, clearly. So first you told that if you choose one booth and you connect with 5, any 5, right? So you took
Yes.
from 15 to 10, correct? 11, 15 to
Yes.
11. Which was the telephone booth number for yours?
Sir?
Which booth you selected first?
15.
15, and you connected till 9, okay?
Yeah, 15 till 10, 15, 14, 15, 13, 15, 12, 15, 11, and 15, 10.
Okay, so then which booth you choose?
9 I chose. So I connected 9 and 8, 9 and 7, 9 and 6, 9 and 5, and 9 and 4.
Wrong. Because, okay, now 9 you have chosen because you have considered till 10, okay? So you
Yes.
are actually not considering about them. Okay, it's fine. Then
I consider I have only 3 booths now left. So 3 booths
Okay.
can be connected only to 2 booths. So I cannot have an exact 5 booth
this is
connection.
not
So my answer
the
is no.
case. This is not the case. Your approach is wrong.
Okay, I know that, sir.
Who,
Yeah.
who told you to not consider the booth which are already considered?
Because the connection
saying
is
that-
saying exactly 5 telephone booths, right? If I
Exactly
connect,
5 telephone booths.
Yeah, so
okay.
only so in your case, 15 has 5, but like for example, 10 has only one connection.
no, 10 has 5 connections, right? To 10 has to 9. Okay.
So you connected 15 to 14, 13, 12,
Leave it,
10, but you did not
No,
connect
see,
10 to.
the question is not directly connected. It is asking just connected.
Correct. But see,
It is
in
not
this case-
asking directly connected, right?
Okay, see, in this case, a telephone booth is not a directed connection. It is undirected graph actually.
Yeah.
Because there is no incoming only.
It is connected to, exchange, let us say.
So you take, according to your logic, if I take 10 booths and try to connect 4 hour, every connection, every telephone had 4 connections. According to your logic, what is happening? You took the greatest one, which is 9, right?
Yes.
Where is 9? And
9 is connected to 8.
8.
9 is connected to 7.
9 is connected to
7.
7.
9 is connected to 6.
9 is connected to 6. Okay.
9 is connected to 5.
9 is connected to 5.
And 9 is connected to 4.
I am taking 4. Okay. Okay.
And 4 also, because we have 5 connections, right? So I took 4 also.
Okay. Take it 4.
Now I have only 3 booths left, which is 0, 1, and 2.
0, 1, 2, 3.
0, 1, 2, 3. Okay.
Then
now 0, 1, 2, 3. How many connections I can have between them? Maximum I have 3 connections. 3 to 1, 3 to 2, 3 to 1, and 3 to 0.
But why not 3 to 9?
So if 3 to 9, if I connect, then 9 will have how many connections? It will have 6 connections, right?
So why not 3 to 5?
Again, 5 will have 6 connections.
Why?
Because they are already interconnected, right? 15,
No,
9 is already
5 has already only one connection.
Now it will have 2 connections.
Because it is not, see, if 9 is connected to 5, which means 5 is also connected to 9. Because it's a transitive.
So there is only one connection, no? For 5.
It is transitive, right? In this case.
You are making transitive is what? Transitive is A to B, B to C, then C to A, correct? So in this way, you are making it click by in your mind, but question did not say you to make it click.
Okay.
Okay, so so there are 6 neighbors, okay, and it doesn't matter that one person will have connection with everyone. He can have any 5, okay.
Okay, sir.
It's not that I am liking my neighbor A and neighbor A is liking B. It doesn't matter, B will like me.
Okay, right.
So it's not the click. You are making in your mind that you have studied click and you are applying it click, because there is nowhere said that click is in the picture.
Okay,
as you are
sir.
saying 9 is connected to 5, then according to you 5 is connected to 4, right?
Right, sir.
That is click, and question doesn't tell that click. Question only tells every booth has 5 connections. That's all. Nothing else.
Exactly 5 connections.
Exactly 5 connections. Nothing else.
Okay.
It is click or not, no matter. Okay.
Okay. So can we, sorry, sir, can we just go to the answer which is given there? How they derived that answer, sir? Because they have given some calculation.
That is a very good calculation. Okay. Now you understood that where you are making a mistake, right?
Yes, sir. Yes.
Okay. If you understood, then I'll take quite simpler example. 1, 0, 1, 2, 3, 4, and 5. Okay, I'll take 5. Okay. Okay. I am saying every person has exactly three connections. Now you connect it. Okay. The question is there are 5 nodes and every node has 3 connections. Means 3 edges. How will you connect it? 0 to 1. Why is it 8 here? Okay.
0 to 1, 0 to 2, 3, 0 to 2, 0 to 3.
0 to 3. It doesn't matter where I'm doing, but I'm just taking 3 connection, correct?
Yes.
Now take 1. 1 connection is already there, right?
Yes.
For simplicity, you actually count the connections. How many connections are there? Okay. 3, correct?
Yes, sir.
Now 1 is already connected. Take 1 to
5.
2
and 1 to 5.
For simplicity, we are taking sequence. Okay. 2, 1 to
5.
3.
1 to 3 and 1 to 5.
Okay, 3 connections done. Is that right or not?
Plus 2.
Plus 2. Okay. Now
5, 2 and 5, 3.
2 to 5.
Plus 1.
And 2 to, no, we cannot do any more. It is already 3. So delete it. 2 is already has 3 connections, right?
No, sir. 2 has only 2 connections.
No, sir. 2 has only 2 connections.
We'll have to draw one more connection.
Okay.
2 to
So
5.
this one more.
Plus 1.
Okay. Now we are talking about 3. 3. I draw it later or first? Okay, later. That is not required. Okay. Now 3 only can connect to 5. Is that right or not?
Sir, why not 1, sir?
1 already
One has 3.
Already has 3.
Okay, yeah.
Okay. Fine. So how many connections I have?
Plus 1.
How many total?
7.
7.
7. Okay, give me a logic, man. I told every connection will have three. Every node will have three connections, correct? Is that right or not? What I told, every node will have three connections.
No, sir.
Correct?
It's not.
No, sir, wrong,
Yes,
sir. Because three has two.
Three has only two connection.
3 has only two connections. So where should I give it? So the problem is that we are not able to connect. Am I right?
Yes, sir.
Why we are not able to connect? Can anyone give me the logic? Does anyone have any answer? Why we are not able to connect it? So did you read about the degree or not?
No, sir.
No,
Yes,
sir.
sir.
The maximum edges will give us the degree.
Okay.
The
So
Yes,
neighbors,
sir. Some of
total
any.
neighbors will have the degree. That is the
Yes,
degree.
sir.
Okay. So this is a one graph. What is the degree of this graph?
1.
It's 2, right? 1 from 1 and 2, second from 2.
Okay, you have to consider both. 1 is a neighbor of 2 and 2 is a neighbor of 1.
Correct. So the thing is that if there is an edge, it will connect two nodes. Okay.
Yeah.
If there is an edge, then it will connect two nodes.
One edge will connect two nodes.
Yes.
So n plus 1, node plus 1.
No.
Sorry, h plus 1.
So by
Should
this
be
way,
the number of nodes, right?
By this way, there will be a problem then for you. How many edges are here?
Here 3 edges are there.
3 edges are there. How many nodes are there?
3 nodes, so it will be 6 edges, right?
Degree 6.
It will be 6 right here.
Mm-hmm.
You are calculating like one node is 2 edges.
Right.
Then it is
degree is 6.
Yeah, one edge. Yeah.
So the question is here in the small graph, I'll say if one node has two connections, okay? Right or not? So total, how many connections are there?
No, sir, I still did not get
One
this.
node has two connections, okay?
It's 9 or
Then total connections will be 3 into 2. But in directed graph, one is being counted twice. Are you getting point? For example, if I say there are total 6 edges, 1 has 2, 2 has 2, 3, 5 has 2. Is that right or not? Are you getting my point? 1 has 2 connections or not?
Yes, sir.
2 has 2 connections. So 4 connections. 5 has 2 connections. 6 connections. But the problem is that 1 and 5 sharing the same edge. This means every edge is being counted twice, right?
So I think it should be, but in undirected graph, one edge is being counted twice.
In undirected graph, right? This is in undirected. Okay, sorry.
Directed.
Undirected. Okay.
Yes, sir.
Yes.
So total number of edges is equal to 6 by 2. Correct. 3. Is this satisfying this small graph?
Yes, sir.
Let's check the bigger graph. I'm saying there are 5 nodes and every node is connected by 3 nodes. Okay. So how many edges are there? 5
into
3 divided by 2, which is 7.5. And this is not possible. That is why we were not able to draw this. Huh?
Okay, sir.
Now you got my point.
Can we do this way, sir? This logic will work out. I'm just asking.
Yeah.
Like there are 15 nodes and then we need to have 5 connections.
Correct.
So now if you are connecting 15th node with 5 other nodes, totally 6 nodes are involved there.
Totally 6 nodes are involved there. Correct.
So if you divide 15 by 6, which is giving you 2.5, which is a fraction.
Again,
so it is not possible.
You are making it click. Again, you are making it click.
Right?
No. You are again making it click.
Click, huh? Okay.
You are grouping by 6, correct?
Yes.
And again, those will not be connected outside of 6, correct?
No, see, if the question is 18 telephone booths and 5 exact connections, then it is possible, right?
18
instead of 15, if I have 18 nodes.
Correct.
With 5 connections, it is possible, right?
Yeah, it is possible.
Yes, sir. It is possible.
So if it is possible, because say 18, if you are connecting 5 nodes, 18 divided by 6 is 3, which is a whole number. Because it is a whole number, it is possible.
There is one issue in this.
If you are taking 15 nodes, 15 divided by 6 is 2.5, which is not possible. So I worked on that logic. I don't know whether it is working only for this scenario or it is a common logic. I am not able to judge that.
So there is one issue with this, that you are making it a click graph.
Okay.
Your logic is actually giving the correct answer.
Okay.
So there, if you are saying that there are 18 nodes and everyone is connected with 5, which means 18 into 5 divided by 2, which means 45 edges will be there.
Yes, or I will divide 18 by 6, because say if you want to connect one node with 5 nodes, actually 6 nodes are involved there. So I am dividing the total nodes by 6. That's it. So if I want to connect 18 with 4, so if I want to connect each node with 4 nodes, then totally 5 nodes are involved there. So if I divide 18 by 5, it is a fraction. So it is not possible.
Okay. So
what about those if we have 25 nodes?
With
5,
it is possible. 25 with sorry.
Karthik,
yes, sir.
Okay, Karthik. Take according to your logic, I'm saying there are 3 nodes and everyone is connected with 2 nodes. Give me the answer.
3 nodes, everyone is connected to 2 nodes. My logic, it has to come, it is possible, but it is not possible.
Tell me your answer. It is possible or not?
According to my logic, it is possible.
I'm saying there are 3 nodes and everyone is having 2 nodes or 2 edges. That is possible, right?
Yes.
According to your logic, you will create a group of 3, correct?
Yes.
Now again, there are 4 nodes and you are connecting with 2 edges. Every node has 2 connections.
It is not possible.
That is actually possible. Take a rectangle, right?
Okay.
Take a rectangle. That is possible. And according to your logic, there you are failing it.
No, every node has to connect with exactly 2 other nodes.
Correct.
Yeah, it's possible in square, no?
So you will map, you will create a group of 3, correct? According to your logic.
I'll create a group of 3. Yeah.
And 1 is left. That is not possible, huh?
Yes.
Because you need 2 more.
Yes.
Yeah.
Again, your logic is getting failed. That is what I'm saying. You are making a click.
Okay.
And according to my logic.
So can I mean, understand the logic, sir? How you derived such a 7.5 so that I
am saying there is one node. If it is connected with, it is having 3 connections, means it is actually from it 3 edges is being passed, right?
Okay.
So if our node is having 3 connections, means there are 3 nodes which is connected to that node, correct?
Yes.
So how many total number of nodes will be there? How many total number of edges are possible there? So if everyone has 3, then 3 into number of nodes. But there is a case that every edge shares 2 nodes.
So we have to divide for.
We have to divide by 2, which is being counted twice. It is the same thing you were studied in the week 1 mathematics intersection, where you were saying count A, count B. But in that way, you are counting A into A intersection B twice.
Okay.
Yes, sir. Yes, sir. Yes, sir.
So you had to reduce it, correct?
Mm-hmm.
So if you want to talk about A union B, then A plus B, A plus B minus A intersection B, right?
Yes.
That is the same logic here being applied. If I have 5 connections, so I will get 5 edges. Sorry, 5 into 3 edges. But every edge is sharing 2 nodes, which is actually reducing by half.
Okay.
So every edge is being counted twice. For example, let's take this. So 0 is having 3 connections. Okay. So I counted 3. But when I talked about 3, it has 3 connections. Take 1. It has 3 connections, but this connection is counted twice. Am I right?
Yes, sir.
Yes, sir.
Similarly, if you talk about 2, this connection will be counted twice. And this connection will be counted twice. If you talk about 5, then this connection will be counted twice. This connection will be counted twice. Only this connection will be counted once. Am I right or not now?
Yes, sir. So we will have to remove the half of the connections. That's why we are dividing by 2.
Correct. So the same logic was given in the, if every node has 5 connections, then total number of connections will be n minus 1, n into n minus 1.
Here, what is n, sir? It is 15, right?
Yes.
There is a
It should be n into m minus 1.
M into n, not m minus 1, no?
So n is the number of
wrong.
nodes and m is the number of edges.
Should be n into m by 2, maybe.
Correct. N
Yes,
into
sir.
m by 2.
N into m by 2.
Your calculation is right.
Yeah.
This formula is incorrect. Okay.
It is n into m by 2, sir. That's what I got confused, sir. How it came. I mean, this logic.
Okay. This is for when every node is connected with every node. Okay.
Yes, it's from different lesson.
Yes, sir.
So if the number of nodes are odd and the number of edges are also odd, then in that case we will not get. This is not possible. If the
number of nodes and number of edges is not odd, then you are
both
saying
are
not
odd.
possible
Both are
because
odd.
you are dividing 2 and it is coming. So is there any one? Is there
Yes,
any?
sir. Odd
Actually, it is
odd
a
into
number
odd
of nodes into number of connections divided by 2.
Yeah,
So
so
he's
odd
saying
into
that
odd
if
will
both are
always
odd,
odd.
then there is not. It is not possible actually.
Yes, sir.
Can we get any example where it is possible?
Even if one
I
of
guess-
them is even, even if the number of nodes or the number of edges is even, then it is possible. If the number
Okay,
of
so
nodes is
odd
even,
multiplied by odd always give odd, right?
yes.
Yeah.
Yes, sir. That's
Oh
why
my
it does
God,
not
you gave a
multiply
correct
completely.
answer. It is a good idea, man. Now we have one formula.
Yes, sir. It's
Super. Thanks.
yeah.
I even did not think about that. Okay, so I hope this question is clear to everyone now. Is that right?
Yes.
So you are supposed to see the how many connections are being, and if you divide by 2, is this a even number? Sorry, is this a integer or not? Correct? If it is a fraction, then that is not possible. And the logic I have given. Okay. Anyone else? Any question?
So when will the answer key for the quiz will be released?
Maybe by tomorrow, not tomorrow, by Wednesday, Thursday.
Okay.
So can we have a click in a directed graph? Like if we have connection both way, so we will still
Then
call
it will
it a-
become undirected graph.
Yeah, I get it, but like for example, rest of the graph is like still directed. Can we say that that particular section is a click?
I am not sure about that, but yes, it will be, because the definition is every graph should be, every node should be connected with every node, right?
Yes.
Perhaps, but sir, perhaps in directed graph there are cycles, concept of cycles.
But we can have
So-
two-way connections as well. So like A is connected to B and B is connected to A.
Sir, can you take a question?
That is what I'm thinking. I don't have any example. It is actually if you study DAG into the mathematics, do you understand? Do you get DAG? Directed acyclic graph, right?
Okay, sir.
But there is something where if you try to reach using more than 2 ways, 2 nodes in as intermediate. For example, so if I talk about reachability, you have studied the reachability in mathematics. You guys have studied the reachability in mathematics or not?
Yes, sir.
Okay. So what happened? If I talk about, is one reachable from one or not? No, it will not also give me the correct answer. Okay. If I take example of trains, so mostly 2 trains, there are 2 trains which is coming and going back, right?
Yes, sir.
But in a imaginary scenario, okay.
So are you talking about cyclic graphs?
No, I'm not talking about cyclic graph. I'm trying to make you understand that when it will be, when you are visualizing click, right? So in
Yes.
directed graph, if if it is a directed, okay, it means there is at least one edge which is not both directed in the both direction, okay?
Yeah, so I was just saying, for example, in this one only, so 1, 8, 2, and we can take the example of 0. So like if we have connections from 1 to 0, 1 to 8, 1 to 2, then we have from 8 to 2 and 8 to 1, and then we have 2 to 8, 2 to 1.
Then this will become already the undirected graph. That is what I'm trying to say. If both, if you find 2 ways, the 2 ways of a row, it is actually undirected graph. That is what it means.
No. So for example, like if we have only directed from 1 to 0, but rest of the 3 nodes are connected both ways.
So that will become click actually. I have to get it clear, but in my opinion, it should be click, because in a click, every graph should be, every node should be connected with every node.
Yes, sir.
If I don't remember the definition, was it said that undirected, it should be an undirected graph in the lecture?
I'm not
Yes, sir. He was mentioning in the lecture that.
I'll get it clear. I am not sure. Okay.
Okay, sir.
Okay.
But logically, I also feel, but I need to get it clear there, because by definition, it is or not. Okay.
Okay, sir.
But the case you are talking is very rare. Everything is directed and a small part is undirected. Okay.
Yes, I guess.
That is a rare part. I am not getting any example on that. Okay. Any other question? Okay, so I hope most of you have not studied the chapter. I request you to go and study the chapter because week 9, 10 are going to be really difficult chapters for you. In CT, everything was easy till now. These 3 chapters will actually be very, very tough. Especially in week 10. If you don't understand week 9 and 10, week 11 will be very tough for you. But you have cleared the week qualifier and hope you will get good marks in quiz 2. So you can do, but you need to do a little bit efforts, more effort. And in compared to other subjects, actually other subjects are getting finished 1 week earlier from city, if I am not wrong. So every week is actually getting submitted by week 10, right? For other course, week you are supposed to submit week 10, not week 9. Am I right?
Yes, sir. Other course are 1 week ahead, sir.
Yeah. So you will get time for city. That is a good part. And manage your time by that. Don't forget about the deadline because this time deadline are on Sunday. So be prepared with that. Friday will be the solve with us session now.
Sir, will you provide summary?
Sir, I have one doubt, sir, if you have time.
Yeah, tell me.
We will come back to the example which you have given, like there are 4 nodes and it has to connect to 2 nodes exactly. Each node has to connect to 2 nodes exactly. So is it possible or not possible, sir?
According to it is possible.
So how, sir, can we have an explanation like how it is possible, sir?
4 into 2 divided by 2 is equal to 4.
Okay. So can we, represent something graphically like 1 is connected to 2 and 1 is connected to 3?
It's rectangle, man.
Square, rectangle.
Okay.
Just imagine the rectangle. Every node has 2 connections. And exactly 2 connections.
Okay.
This one.
Oh.
Not rectangle, quadrilateral, if I say.
Quadrilateral?
Yeah. So this has 4 connections. Every node has 2 connections and there is a possibility. Is that right?
Okay. Yeah.
You got your answer or not?
Yes, sir. Yeah.
So because the same logic I'm applying, every node has 2 connections. There will be
so m into n by 2.
Yeah, there will be 8 connection, but in undirected graph, every edge is being counted twice.
Okay.
So divide by 2. That's all.
Okay, sir. Okay.
Sir, will some on-demand session? Will some on-demand session will be conducted for week 9, sir?
If you come now without studying here, how am I get motivated for on-demand session? If Monday is the solve with Monday is the open session for city, then there will be only 1 session in that day. Okay. And you are supposed to study at least half of that both subjects to come in that.
Oh yes, sir. We'll do that, sir. Actually, we require, sir, some on-demand session for this week.
Okay, I'll try to arrange one. Okay,
okay, sir. Thank you. Sir.
That will be sufficient. 1 on-demand session before solve with us.
Yes, sir. That will be sufficient.
Yes, sir.
Okay, super. But problem would be the timing because it can get clashed with other subjects. So you need to manage that. Okay. Guys, should we close the session now then?
Okay, sir.
Okay, thank you everyone. Thank you very much.
Thank you,
Thank you, sir.
Thank
Thank
you,
you.
sir.
Thank you,
Good night,
sir.
sir.
Good night.